Okay, Wildcat, so we're at 11.1, Fitting Exponential Functions to Data Assignment Tutorial. Question 1 of 10. Determine whether each set of data can be modeled by an exponential function. If it can, tell whether it represents exponential growth or decay. If it cannot, tell whether a linear quadratic model is instead appropriate. All right, so there's our table. All right, step 1. Find the ratios of successive terms. So 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. 162 divided by 54 is 3. So step 2, the ratios are constant and greater than 1, so the data can be modeled by an exponential growth function. All right, go ahead and finish up question 1. All right, question 2 of 10. Determine whether each set of data can be modeled by an exponential function. If it can, tell whether it represents exponential growth or decay. If it cannot, tell whether a linear or quadratic model is instead appropriate. So there's our table. All right, step 1. Find the ratios of successive terms. Okay, so the first difference. So 2 plus 1 equals 3. 3 plus 1 equals 4. 4 plus 3 equals 7. 7 plus 4 equals 11. And 11 plus 5 equals 16. So the first differences, they're not the same. So now let's look at the second difference. But we need to use the 1, 1, 3, 4, and 5 from the first difference. Okay, so 1 plus 0 is 1. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 1 is 5. So the second difference is not the same. So step 2, the first differences are 1, 1, 3, 4, and 5. They are not constant. Step 3, the second differences are 0, 2, 1, and 1. They are not constant. Step 4, the ratios. 3 divided by 2 is 1.5. 4 divided by 3 is 1.3. 7 divided by 4 is 1.8. 11 divided by 7 is 1.6. And 16 divided by 11 is 1.5. So the first and second differences are not equal and the ratios are not constant. So the data are neither linear, quadratic, or exponential. All right, go ahead and finish up question 2. Okay, question 3 of 10. Determine whether each set of data can be modeled by an exponential function. If it can, tell whether it represents an exponential growth or decay. If it cannot, tell whether a linear, quadratic model is instead appropriate. So there's the table. Okay, find the ratios of successive terms. So first difference. Okay, so 2 plus 6 equals 8. 8 plus 8 equals 16. 16 plus 10 equals 26. 26 plus 12 equals 38. So the first difference is not the same, so it's not a linear model. Now let's use the 6, 8, 10, and 12 from the first difference to look at the second difference. So 6 plus 2 equals 8. 8 plus 2 equals 10, and 10 plus 2 equals 12. So the second differences are the same. So step 2, the second differences are 2, 2, and 2. They are constant, so the data can be modeled by a quadratic function. All right, go ahead and finish up question 3. All right, question 4 of 10. Determine whether each set of data can be modeled by an exponential function. If it can, tell whether it represents an exponential growth or decay. If it cannot, tell whether a linear quadratic model is instead appropriate. So there's our table. Okay. All right. Step 1, find the ratios of successive terms. If necessary, round your answer to the nearest 100. So 66.8 divided by 76.8 is 0.87. 58.8 divided by 66.8 is 0.88. 50.6 divided by 58.8 is 0.86. And 45 divided by 50.6 is 0.89. The ratios are approximately constant and less than 1, so the data can be modeled by an exponential decay function. All right, go ahead and finish up question 4. All right, question 5 of 10. Temple Wildcats are asked to find an approximate exponential model of the data in the table. So here's your table. Okay. Step 1, find the a value of the exponential equation f of x equals a times b to the x using the first data point, 0, 10. So we have f of x equals a times b to the x, okay, where x is 0, and f of 0 equals 10. So f of 0 equals a times b to the 0, which equals 10. Well, that's a times b to the 0 is 1, equals 10, so a equals 10. Okay. Step 2, find the b value of the exponential equation f of x equals a times b to the x using the ratio of the first two data points. Well, the first two data points are 0, 10 and 1, 6.2. So we find the ratio of 6.2 divided by 10. Okay, so let's put that in our calculator. So 6.2 divided by 10 is 0.62. Okay, so the exponential model is f of x equals 10 times 0.62 to the x. All right, let's go and look at the next question. Okay, example 6 of 10. Temple Watkins are asked to find an approximate exponential model for the data in the table. Okay, so here's your table. All right, step 1. Find the a value of the exponential equation f of x equals a times b to the x using the first data point. First data point 0, 10. This x is 0. F of 0 equals 10. So f of 0 equals a times b to the 0, which is 10, which we know is, again, a times 1, which equals 10. So a equals 10. Step 2. Substitute 10, 0.6 into the f of x equals 10 times b to the x and solve for b. So we know that f of x equals a 0.6 and x equals 10. So we have f of x in for 0.6, but now we need to plug 10 in for x. Okay. Now at this point, we're going to graph the left side and the right side and find the point of intersection. Okay. So let's do that now. So we're going to go to Desmos. Okay. So we're going to graph y equals 0.6 and y equals 10 times, we're going to have to use x instead of b, x to the 10th power. Okay. Click right there. We want the positive value. Okay. So the b value is 0.755. So our equation is f of x equals 10 times 0.755 to the x power. All right, go ahead and finish up question 6. All right, question 7 of 10. Temple Wildcats are asked to find an approximate exponential model for the data in the table. So here's your table. Step 1, find the a value of the exponential equation f of x equals a times b to the x using the first data point, 0, 9.4. So this is x. This is f of 0. So f of 0 equals a times b to the 0, which is 9.4. So then that's a times 1 equals 9.4. So a equals 9.4. Okay. Step 2, find the average of the ratios to estimate b. So we need to put the ratios divided by 10 to find the b value. So let's do that now. Okay. So we're going to press Control Divide. We know we're going to divide by 10. Come back up here. Let's put parentheses, Control Divide. 6.9 divided by 10 plus Control Divide 5.6 divided by 6.9 plus Control Divide 3.7 divided by 5.6 plus Control Divide 3.5 divided by 3.7 plus Control Divide 2.7 divided by 3.5 plus Control Divide 1.5 divided by 2.7 plus Control Divide 1.1 divided by 1.5 plus Control Divide 1.0 divided by 1.1 plus control divide 0.8 divided by 1.0 plus control divide 0.5 divided by 0.8. Press enter, and then they want it, let's put 0.75. Okay, so the exponential model of f of x equals 9.4 times 0.75 to the x. All right, go and finish up question 7. All right, now for question 8, I recommend using the step-by-step process to help you answer question number 8. Also, question 9, use a step-by-step process. And question 10, use a step-by-step process to answer question 10. All right, with that, go and finish up your assignment and have a wonderful Wildcat day.